Another little quick informative video. 400 boost valve, Sunex replacement with O-rings. On a boost valve, 400 and a 480. This larger land, on most transmissions, this larger land is the reverse side of the boost valve. So your regular either torque signal in the case of a 480 or modulated modulator signal acts on this land, and so it gets the whole diameter of that. When it goes in reverse, it's acting on this land and the larger land right here. So what happens on a 400 is if you leave that stock, you leave the valve body all stock, and you put a modulator plug in place of the vacuum modulator, when you go into reverse, you can see 400 plus pounds of line pressure in reverse under throttle, you know, or really anytime, just above idle, because this thing's boosting both circuits and really pushing on the pressure regulator valve. So a couple different ways to kill reverse boost is to grind a flat on here and then plug the pump so that no oil goes to right here to the boost valve of the pump. And I'm gonna leave that to you guys to track in the pump. You should be able to figure that out if you desire to. You should be able to figure it out. But you know the oil goes in here to act on the reverse side and the inboard end of the boost valve, and then your regular modulator oil goes in this outboard end closer to the snap ring. So plugging the pump and grinding the land off this is perfectly fine. We still do it in certain cases depending on what we're doing with the valve body. But generally what I like to do is when I build the valve body is to make it happen in the valve body. So an example here, this valve body is not modified for it, but it happens in the plate, but I don't have that plate here. But this plate is kind of a generic plate, pretty close to stock. It goes on here, and if you look, open the valve body back up. This little L-shaped passage near the front, that's an exhaust. That is reverse. So your manual valve takes line pressure, puts it in reverse neutral drive, and reverse when it's in the reverse position. So it goes through here in the plate, it jumps through the case to here in the valve body, and it follows the valve body up to here. It goes in the case, through the pump, and to your boost valve. And then from there, it goes back and around to reverse back here to get it to the band, and it wraps back up here to the 2-3 shift valve to loop it in to get reverse to the center support the other way, kind of to dual feed reverse. Well, as you can see, this plate has both passages here. So it's going to make it from reverse to here, through the valve body to here, to the pump. What we often do is when we make a plate, we kill the passage that would be approximately here, as it's done on this plate. So we still have reverse here, it can feed reverse and activate reverse, but it doesn't make it to the boost valve. We leave a hole here, so that goes to the boost valve, so it's an open passage to here. And then we mill a slot in the valve body. You could drill a hole through here too, or you can mill a slot here or there, anywhere on this passage outside the valve body to relieve any residual pressure that we get on this boost valve. It gives it a place to bleed. So you've killed the feed by plugging the hole here, but you also have to create an exhaust, because if you don't, it doesn't matter how new this boost valve is, how great the machining is, a little bit of oil is always going to leak by from your normal boost side in between to your reverse boost side. And if you don't grind a slot on this or put a relief in the valve body somewhere, that oil that slowly leaks past will act on the reverse side, and you'll have uncontrollable line pressure. Like you'll have way higher line pressure than intended, and it won't be consistent. So anytime you plug the feed to something, you also have to create an exhaust. Otherwise you can have a slow buildup of uncontrolled pressure. So that should be hopefully a little bit of a lesson. But plug the feed to and then create an exhaust somewhere in the circuit. You can plug it at the pump, create the exhaust right here at the boost valve, or you can plug it at the beginning of the reverse boost circuit, is what I call this, and then create a leak anywhere on this, and you have killed reverse boost. And typical stock deal, you're running 50 pounds of line pressure at idle. with modulated line pressure, you need reverse boost because you want it to come up. You know, you're going to need 100 pounds to get the band clamped good. And you know, these things were used in trucks, 1 tons, where you're going to be hooked up to a trailer. A lot of times you might be backing a horse trailer or a car trailer or some type of trailer up a hill, up an incline, so you need plenty of pressure in reverse. Reverse is a 208 to 1 ratio on one of these things, so the way the direct clutches see that is actually kind of a double overdrive acting on the clutch. Yeah, the output shaft sees gear reduction, but the clutch doesn't because it's all driven backwards. So that kind of gives you an idea. Reverse boost. It was brought up yesterday in one of the groups, so this should give a little bit of a idea how to do that, or to look to see if it's been done on the valve body you're using. You know, if it's got a slot here or off the plate, it can even be made into the plate where it's just a opening made in a plate to exhaust the oil, because it's not going to be a lot of oil. It's just whatever bypasses on the boost valve.